Alright, let's take a look at this problem. See the requirements. We need to read three sides of a triangle, and if the triangle is right-angled, we output true, so we can just use print true, and otherwise, if it's not a right-angled triangle, we output false. We are given that all inputs are integers, and of course they are valid sides of a triangle, so no need to worry about the given numbers being negative or something. So first of all, we need to read the inputs. So we need to convert the input into integers. Let's say enter first side. So we copy this, paste, make a few changes. B is the second side, and C is the third side. So this is reading the input. We're done. And now, speaking of determining how three sides could form a right angle triangle or not, we would naturally come to the Pythagoras theorem. So that is, if there's a triangle with sides x, y, and z, and square of x plus square of y is square of z, then we could say the triangle formed by x, y, and z is right-angled. So there is one little problem, is that we don't know which of A, B, and C should serve as the z in here, and the other two would serve as x and y. So to make sure that we cover all possibilities, we need to consider the three possibilities that A is plugged into Z, B is plugged into Z, and C is plugged into Z. So we need to use OR to link them up. First of all, we consider square of A. Notice that we use 2 times operators for the power operator, and plus square of B equals square of C. Remember to write 2 equation signs instead of 1. So this stands for equals, while 1 equation sign is for the assignment operator. Or square B plus square C equals square A. Or square C plus square A equals square B. If any of these three possibilities stands true, we would know that the triangle is right angle. So in this case, we would print true. So other than these three cases, the triangle would not be right angled. That is, else, we use else for other cases and print false. So that is basically a trivial solution to this task. We could give it a test. Python and plus the name of the file, which is right angled triangle .py. So we need to enter the three sides. Let's use the basic 3, 4, 5 combination. 3, 4, 5. We could say that our program is outputting true. Maybe we could change their order a bit, like 4, 3, 5 is true too. And if we put 5 in a different place, like 5, 4, 3, or perhaps 4, 5, 3, we could see that the output is also true, true. However, if we try a combination that is not right angled, for example 4, 5, 6, we would get false. Now, I know some of you would think that this is way too long and I feel it's not very efficient. Of course. So we could have a more flexible solution. See, if we added square of z to both sides of this equation, so on the right-hand side, it will be 2 times square of z. In this case, the left-hand side would always be the sum of the square of the 3 sides. So in our variables, it's square of a plus square of b plus square of c. And the right-hand side, we only need to determine which of a, b, c is the largest. And fortunately, we have one function for that. That is the max function already given to us. So we only need to input what we want to compare in here. And this expression would output the largest of a, b, and c. So we could try implementing this. Square of a plus square of b plus square of c equals twice the maximum of a, b, and c squared. So notice that Python would take this as higher priority. So like we naturally calculated, and this would be calculated first, and afterwards it would be times 2. However, if you feel that this expression is not clear enough, you could add brackets on your own. So this will make it clearer. Now let's test if we have it. Try again. 3, 4, 5. We could say it's true also. Like 4, 5, 3. 5, 3, 4. Or perhaps for larger triangles, we have 8, 15, 17. Or perhaps 5, 13, 12. You could see that they're all true. And if we give 2, 3, 4, it will be given false. That is a simplified solution